Hello everyone. Today we're gonna start a new chapter which name is atomic structure. In this chapter we will study about the structure of atom, presence of different subatomic particle in atom like electron, proton and neutron, which are negatively charged, positively charged and neutral particle of atom, and their location in atom. Okay, let's start the chapter which name is atomic structure. First, we will we will know what is the meaning of atom. So, atom, it is a Greek word which is atmos. Atmos. The atmos, if we divide in two words which are I and tomos. What is the meaning of A and tomos? Because it is a Greek word. It is a Greek word, and the meaning of A and tomos, as you know, when we use not, no, we use a word before any word. A is meaning of A is not, and meaning of tomos is cuttable or cut. Okay, so now we can easily say that atoms is a particle which cannot cut. Atom is a particle which cannot cut or cuttable. Okay, which is cannot cuttable, or we can also say which is indivisible. Okay, but let me clear. It is the name of atom first suggested by scientist Dalton, but after the theory of Dalton, many scientists discover its subatomic particle like they are proton, electron and neutron. So this atom word suggested by Dalton, but it is not perfectly set for atom because atom also cuttable or dividable in its subatomic particle. But usually we know atom as atom. Okay, let's start the first theory or first postulate, first discovery or and work about atom, which were done by a great scientist which name is Dalton. So in today's lecture we will discuss only Dalton's atomic theory or meaning of Dalton atomic theory and their drawbacks and their features. Okay, let's start the Dalton's atomic theory. Dalton's atomic theory. It was proposed by Dalton in 1808. Okay, let's study about its main feature. What are the main features and what are the main highlight and postulates of Dalton atomic theory? Let's discuss the main feature or postulate. Features and postulate and postulates of Dalton atomic theory. The first feature, which is very important, a very highlightable feature of this theory, is that matter is made up of indivisible which is uncuttable particles known as atoms. It is very important and first postulate of Dalton Atomic Theory. What is the meaning of this postulate? According to if we probably discuss this first postulate, the meaning of it is that all substance are composed or made up of extremely small particles called atom. Okay. According to Dalton, all the substance, our book, our pen, also human body, table, chair, all the things around us are made of extremely small particle, which is known as atom. And it's true, the all substance around us are made up by extremely small particle, which is also atom. But Dalton thought that these particles are single particle and not divisible, which is not true, because after this theory of Dalton Atomic Theory, some scientists like J.J. Thomson, William Crookes, Goldstein, Rutherford, James Chadwick also noticed that atom also cuttable, atom also dividable, atom also have small particle in it. Okay, so we will discuss all these drawbacks in this video, but first discuss the also main feature. So we can say that Dalton wanna tell us that atom atom cannot further dividable or divided. Yes, it is the main meaning of this theory, and he highlighted a very important point that atom, it is very important, so be careful for this point. Atom neither be create. It is true, atom neither be create nor be destroyed in chemical reaction. In chemical reaction. Yes, Dalton told that atom neither be created nor be destroyed in any chemical reaction. So he gave a very important law of chemical combination, which is named as law of conservation of mass. Conservation of mass. It means when a chemical reaction occurs, the mass of reactant in a chemical reaction occur, the mass of reactant is exactly same as mass of product if it completely convert in product. It means if this reaction show 100% yield, which means the whole particle of reactant convert in product. Got it? So was the first important feature or postulate of Dalton Atomic Theory. Let's discuss second important feature of this theory, which is second point is atoms of same element atoms of same element are in identical. Okay, let's discuss. According to him, Dalton theory, atoms of same element, all atom of same element are identical in nature, and it's true. If we take hydrogen element, its all atom are identical in their mass, their size, the chemical nature. We also know that all hydrogen atom can form one bond. All hydrogen atom can form, all oxygen atom can form two bond. All nitrogen atom can form three bond, and like helium form no bond. So he told that uh, atom of given element. And what is element? Element is a pure substance which is made up by only one kind of particle, which is atom. Okay, like iron. Iron rod only made up by iron particles. Hydrogen gas made up by hydrogen molecule. Oxygen gas made up by only oxygen gas. Got it? So give atom of given element are are identical in mass, size, and chemical nature. Okay, so atom of all atom of element are identical in their mass, size, and chemical nature according to Dalton. Okay, the third point of this theory is just opposite of second point. Some like of second point, not opposite. It is atom of atoms of different element atom of different element are different. It's true that atom of hydrogen and atom of oxygen are completely different. Atom of carbon and atom of hydrogen are also completely different. If we look at atom of hydrogen can form gaseous molecule on room temperature, but carbon form very hard substance like diamond, unconductible like conductable like graphite, fullerenes. They are different than from hydrogen, because hydrogen form a hydrogen gas, but carbon form a solid diamond particle, and graphite and fullerene. Some of them are conductible like graphite. Okay, so it's true according to Dalton's atomic theory. Uh, let's write or we will let's explain this theory. This point: atoms of different element are different are different in mass, size, and and chemical nature. Got it? Okay. Let's discuss fourth point of this theory. The fourth point of this theory is atom combine in simple whole number. Atom combine in simple whole number. Simple whole numbers ratio to form compound Guys, if we focus on this particular theory, then this theory also develop our basics of chemistry. It also clear our terminology regarding basics of chemistry, like element and compound. What are the difference of element and compound? It is very important for a learner who start his chemistry, so he can according to me, he should understand properly Dalton Atomic Theory. Now, I agree that uh, this theory is not completely successful, but on the point of view, any learner, he clear maximum point, maximum its basics, his foundation for chemistry. Like uh, 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 we also that notice that what are the element are the particle and the substance, pure substance made by only one kind of particle. Now he talk about compound. Compound are substance which made by different kind of particle, but in fixed ratio. Notice this. Focus on this point, in fixed ratio but whole number ratio. Let's understand this point first. Uh, First, I clear this point for you that chemical chemical compounds are formed when atoms of different element combine in fixed whole number ratio, like H2O, CO2. Let us discuss these two compounds. How H2O form? The H2O formed by chemical reaction between hydrogen and oxygen gas, and it give H2O. If we balancing this reaction, we should apply 2 or before hydrogen and 2 before on H2O. So hydrogen have its atomic mass 1. In this proper chemical reaction, we know that total 4 hydrogen atoms participate in this reaction. So we can say that the 4 gram of hydrogen react with two atom of oxygen. So one oxygen has mass 16 AMU in mole, 16 gram per mole. So we can say that here two atom of oxygen, it means that participate in 32 gram. Okay, and if we notice on this, then they are formed by 4 and 32. You can clearly notice that it formed by 36 gram. Right now it's 36 gram H2O, which is 2 mole of H2O. If you notice that the simple ratio of its mass are 1:8. So always in any chemical equation, in any chemical reaction, if you take 2 mole of hydrogen, if you take 4 mole hydrogen, if you take 6 mole of hydrogen, it always combined by oxygen by 1:8 by mass. Let's take another example for H2O. If we take 4 mole of H2 hydrogen, then you should take 2 mole of oxygen, and it give 4 mole of H2O. Okay. Now in this chemical equation, you can see that the here total hydrogen atom participate in 8 mole. Okay, so 8 mole hydrogen, or 8 atoms of hydrogen, it means they have 8 gram mass, correct? And for oxygen, you can see that total 4 oxygen atom participate, it means they have 64 gram. And if you add this, you get 72 gram of water. True na? It means it is approximately 4 mole of water. Okay, and if you notice that we convert this mass in mass ratio, it show 1:8 again. So H2 always formed by 1:8 ratio of mass of hydrogen and oxygen. So this is the proper formula, proper representation of this point, that atom combine in simple whole number ratio. It is true, है ना? Which is always fixed, not change. Always fixed, not change. Focus on this point. In this chemical reaction 1:8, in this chemical reaction 1:8, and another reaction also it will show 1:8, and always form H2O by addition of 1:8 by mass ratio of hydrogen and oxygen. Okay. Similarly, we can see that we can apply this theory on CO2 also. And everyone, this particular point explain a very important chemical combination law. It is the base of very important chemical combination law, which is law of constant or fixed proportion. This Dalton Atomic Theory is the base of this law of chemical combination law, which name is law of constant or fixed proportion. Sir, who gave this? This law given by Proust. Okay, not Dalton, but Dalton Atomic Theory were the proper base of this law. Okay, Now let's discuss about CO2 also. When we notice another point like CO2, another example, formation of CO2. CO2 formed by carbon and oxygen and give CO2. Here you notice that uh, carbon is solid, oxygen is gas, again it is gas. So in this you can see that 1 mole of carbon atom participate in this reaction. It means 1 mole of carbon atom means 12 gram carbon atom, and 2 mole atom of or 1 mole of oxygen molecule participate in this reaction. It means it participate in 32 gram, correct? And if you add this by according to our law of conservation of mass, simply add this. You notice that it gives 44 gram of CO2. So this was the representation of our Dalton's law of conservation of mass. The mass of a reactant and mass of product always same when reaction completely converting product. Reactant completely converting product and reaction complete. But if you notice there, in this also reaction, here 12 gram and 32 gram of oxygen show a simple ratio. Like if we divide it from 4, we get 3:8 ratio. If you double this reaction, again you get 3:8 ratio. Let's suppose if you react 2 gram, 2 carbon atom react with 2 mole of oxygen atom, then it give 2 mole of CO2, which mean uh, 2 mole of carbon atom mean 24 gram, correct? And it is 64 gram, correct? And it give, simply add this and you get 88 gram. How much is it? Simple. And if you notice this, here is also simple ratio. What is the simple ratio? The simple ratio is this. If the simple ratio of this particular carbon and oxygen, again same 3:8. Divide it from 8. Okay, if you divide it by 8, you get 3:8. It means CO2 have fixed proportion of carbon and oxygen, which is 3:8, and hydrogen have fixed proportion. I'm sorry. H2O has fixed proportion of hydrogen and oxygen, which is 1:8. Okay, got it? So let's discuss the last point of this theory, which is fifth point of this theory, which is chemical reaction involve chemical reaction involve rearrangement of atoms. Okay, it means in any chemical reaction only atom rearrangement, it neither be create nor be destroy. Okay, let me clear this point. Atoms are neither, as we know, neither be create nor be neither create. I think it's neither create nor destroyed in chemical reaction, but but they are just rearranged. They are just rearranged to form new substance. New substance. In chemical reaction, in many chemical reactions, you notice that always atom rearrange from one atom to another atom. Okay. For example, a tautomerism of HCN, which is exist in basic medium. If you don't know about tautomerism, only focus on HCN. In this HCN, the hydrogen atom rearrange on this nitrogen and it give CNH. What is CNH? It is C triple bond N and H, and C have negative charge and nitrogen have positive charge. Why negative charge? Why positive charge? We will discuss this point in another lecture, another chapter, which is chemical bonding. Okay, we will discuss first atomic structure, then focus on periodic table, then focus on chemical bonding. It's my sequence of inorganic chemistry. Also, we will study about physical and organic chemistry. Okay, so if according to me, I suggest that don't confuse on why negative, why positive charge. Let's focus. Let's understand this chemical reaction. In this reaction, hydrogen rearrange from carbon to nitrogen. It go from carbon to nitrogen, and it have negative and positive charge. If you don't want to negative and positive charge, then simply you can write CNH. Okay, what is CNH? It is hydrogen isocyanate, and HCN is hydrogen cyanide. So all these are the important postulate of Dalton Atomic Theory. First point was matter is made up by smallest particle, which is indivisible, neither we create nor we destroy it. Okay, atom of same element are identical in their mass, in their size, in their chemical nature. Atom of different element are different in their properties like mass, size, and chemical reaction. Atom combine in simple whole number and give compound. As we know, we detailed discuss on this theory was law of constant of fixed proportion for formation of H2O and CO2. And last point was that a chemical reaction involve rearrangement of atom rearrange from one atom to another atom in chemical reaction, but it not destroy or not create in any chemical reaction according to Dalton theory. Now this theory also has some drawback and some limitations. When different scientists show that their experiment and their research paper, they noticed that Dalton atomic theory was not perfect. There are some loopholes in this theory, but it was good. It was not bad. It was very good because it gave us basic understanding in chemistry. So let's discuss which are the important drawbacks and limitations of this theory. The first drawback, let's discuss the drawbacks, or you can say limitation of this theory. Okay, the first point was that indivisibility or uncuttability of atom was not perfect point, because atom also divisible in um, uh, electron, proton, neutron. Sometimes nuclear reaction show one atom cuttable and one atom divided into more than one atom. Okay, let's discuss the first point, which is indivisibility or uncuttability of atom is incorrect. Is incorrect. Okay, let's discuss this point by perfect examples. The discovery of subatomic particles like electron, proton, neutron prove that atoms are divisible. Okay, we all know that atom have some small particle like electron, which is negative particle, proton, which is positive particle, and neutron, which is neutral particle. Like if we focus on general structure of atom, we notice that the atom has something like this structure, which is Rutherford model. In this it is electron, and this is nucleus, and nucleus have two particles, proton and neutron. So one atom, it is one single atom of Rutherford. But according to Dalton, atom cannot be divisible any particle, but it is divisible in electron, proton and neutron. And also we can separate these particles. So this point was not perfect, that atom is uncuttable, undividable. Okay, next point. Next we have another proof that atom also cuttable in another atom. What is the meaning of this? Also nuclear reactions can change one element into another. For example, we can say this radioactivity of element. Let's focus on atomic bomb, like uranium bomb. In uranium bomb, which is nuclear reaction, here is uranium has 92 atomic number and 235 the mass number. When we react it with one neutron particle, the one neutron particle can divide a uranium in two atoms like barium and krypton. Barium, which has atomic number 56 and mass number 141, and krypton, which has atomic number 36 and mass number 92. And student, this atomic number show the presence of number of electron and number of protons in atom. So uranium has 92 proton, 92 electron, barium has 56 proton, 56 electron, krypton has 36 proton and 36 electron, and the mass number is the combination of proton plus neutron, proton plus neutron, proton plus neutron. If you focus on 92 plus 92 is the summation of 56 plus 36, but 141 and 141 plus 92 is not exact sum of 235. If you notice on this, you get 233 only. Okay, you get only 233. So in this, if we add on 141 plus 92, we get 233. And if we add on 1 plus 235, we get 236. It means it give 3 of neutron. Okay, 3 of neutron. So this particular chemical reaction, nuclear reaction, show that atom also further dividing or destroy. We can say that atom can further destroy in another atom, destroy and create new atoms. Here, this particular atom, this is atom destroyed, and these are two new atoms which are created, which are formed in this reaction. So the theory of conservation of mass on atom is not perfect, because atom can destroy and atom can create it in nuclear chemical reaction. It also give here huge amount of energy. Why energy, sir? The loss of mass is equal to E is equal to mc square, the theory of relativity. We thought, sir, here is equal mass, no mass destroyed, then why we apply E is equal to mc square? Student, when a nuclear decompose in another nucleus, it emit extra amount of energy, because the foundation of nucleus is very strong, and if you cut that, then it will emit its extra amount of energy. You can say it's potential energy. Okay, so it give huge amount of energy which is used in nuclear reaction, nuclear power plant, sometime disaster of nuclear bomb. Okay, so it gives us a huge amount of energy from loss of mass of this reaction. So let's discuss the second point of this theory. The second point, no, second drawback, not theory, second drawback, second failure of this theory. All atoms of an element its element, okay, element are not identical. So it is also the drawback of Dalton Atomic Theory. Many people thought that, why, sir, why you are telling this, that all atom of element are not identical? Because here is one theory of isotope. What is isotopes? Isotopes are the atoms having same atomic number, like hydrogen have 3 isotope, hydrogen have 3 isotope. Okay, 1H1, 1H2 and 1H3. It has 3 isotope which have equal number of atomic number but different number of mass. So these atoms are known as isotopes. So element is only one. Element is hydrogen. Okay, but hydrogen element show it's 3 type of atom: 1H1, 1H2, 1H3, protium, deuterium and tritium. Okay, so isotope like 1H1, 1H2, 1s3 have the same chemical properties. Student, chemical properties are equal in all three isotopes because they have one proton, one electron. So in chemical reaction, we need only electrons. है ना? So they show same chemical property, but because they have same chemical property, so we can say that it is same element, but different in mass. They show different mass. Okay, so atoms of the same element can have different masses. Okay, got it? So this was the one of the big failure, that he didn't consider isotopes, and also he didn't consider isobars, which is third point. Atoms of different element can be similar. What kind of atom can be similar, but they are from different element? These are isobars. Like isotope, unlike isotope have same atomic number but different mass, but isobar have same. Isobar have like carbon 6, carbon 14, and 7, nitrogen 14. It is isotope of carbon. Okay, carbon 12 and carbon 14 are isotope. So you notice that this is not similar, but this mass is similar. So this kind of atom are known as isobar. So it is a pair of isobar. Okay, you can say that it is a pair of isobars. So isobars, for example, carbon 14 and nitrogen 14 are atoms of different element having same mass number. Okay, so this theory also not perfect fit on isotope and isobar. Also, fourth drawback is does not he doesn't show any proper structure of atom. Okay, and the nature of atom and nature of atom in their molecule, like bonding nature. Okay, so fourth point is also very important drawback, does not explain structure of atoms and their bonding. Okay, and their bonding. So we can say that no mention of electron orbital structures of atom and their bonding in molecule in this theory. Okay, so also we can say that chemical bonding can't explain by this theory. Correct. He didn't give any clue about bonding. What are the chemical bond, how the molecule form by different kind of bond. He showed that atom combine and form molecule, but what kind of bond present in molecule? Okay, so this theory also not explain the proper bonding theory. The fifth point, if we discuss on fifth point is fails to explain the existence of compound with same elements in different reaction So this theory not perfectly explain law of multiple proportion, but explain law of conservation of mass and law of constant proportion. But law of multiple proportion not explained by this. So let's discuss what is the law of multiple proportion and why this law can't be explained by this theory. Law of multiple proportion was not fully explained okay, because what is law of multiple proportion? The law of multiple proportion say that if two elements combine, they can form more than one kind of atom, more than one kind of molecule. Okay, like carbon and oxygen form carbon monoxide and carbon dioxide, which are two different compound. But in these compound, carbon have fixed mass, but oxygen have different mass, but they are present in simple ratio. For example, if you notice this, it formed by carbon and oxygen. It also formed by carbon and oxygen. And if we notice on the mass of carbon is in CO is 12 gram and for oxygen is 16. Here 12 and oxygen for oxygen is 32. They show simple ratio like 3:4, 3:8. So this ratio is remain constant, but mass of oxygen in both compound are different. In CO, oxygen participate one atom, but in carbon dioxide, oxygen two atoms participate in this formation of CO2. But he explained properly. Theory of atomic theory of Dalton was based of law of constant proportion. Okay, the law of constant proportion was that H2O form and CO2 form, whether the source and what is the formation of reaction always show fixed proportion. Right now, when at hydrogen and oxygen combine, they always give fixed proportion. Okay, but in this particular example, when carbon and oxygen combine, they do not always show a fixed proportion. They show multiple proportion. In carbon monoxide, it show 4 proportion with 3. In carbon dioxide, it show 8 proportion with 3 of carbon. So it is the multiple proportion. Okay, but okay, understand? So it was not complete explanation of law of multiple proportion. Okay, let's discuss next point. Next point is our last point. Okay, the last point is does not account for allotropy. You know, allotropy or allotropes are different forms of same element. He think that one element form in one type of form, like hydrogen always form in H2 gas, oxygen always form in O2 gas. He doesn't notice that oxygen also exists in O3. Okay, he assumed that always oxygen exists in O2, but O2 is not only one form of oxygen in nature, also ozone is the another form of oxygen. Like carbon, he thought carbon is present in always in diamond, but carbon also present in graphite. The diamond and graphite are two different forms of carbon which are present in nature. Also, one man-made allotrope, one man-made form of only combined by carbon, which is fullerene. And many of these, coke, coal tar, these are many of other forms of carbon. If we notice on phosphorus also show three type of allotrope. White phosphorus, which is naturally occur when we heat and apply some pressure, it convert in red and black phosphorus. So these are also form of phosphorus, but exist in different kind of form, also in color, also in geometry, also in nature. Okay, so he didn't explain any allotropic form. So this theory cannot explain why the same element can exist in different physical form, like allotropes. For example, carbon is graphite, diamond, and fullerene. So this was our Dalton's atomic theory. He show that what are the main features. First feature is matter is made by undividable particle, which is known as atom. Atom of same element are identical in nature. Atom of different element are non-identical in nature. Atom combine in simple ratio give a compound in simple ratio. And in chemical reaction, atom are only rearranged, not destroyed or not created. There are some drawback or limitations of this theory. Indivisibility or uncuttability was not true. Atom can also indivisible. Atom can also cuttable in any chemical reaction like uranium in the nuclear reaction. Indivisible mean atom has some subatomic particle like electron, proton and neutron. All atoms of same element are not identical because there are some isotopes of any elements. Isotopes which show same atomic number, same chemical nature, but different masses are isotopes. Different elements atom are not identical, not have similar property, any kind of similar property, but there are different elements like carbon and nitrogen have different chemical properties like uh, 7 and 6 proton, but show same atomic mass, same mass number like 14 14. There are these are isobars. Does not explain structure of atom and the bonding in molecule. Also, he fails to explain law of multiple proportion. Okay, and he doesn't give any clue about allotropy form of element. So this was our first lecture regarding atomic structure, in which we discussed our first theory, Dalton Atomic Theory. It was very detailed explanation according to me. So I think it was the perfect for starting of atomic structure. So let's discuss next theory, next points of atomic structure in next lecture. Okay.